So welcome everyone. Thanks for joining this webinar, joint webinar between 6GIA and AIOTI to present the joint white paper on the role of 6G in agriculture. Let's just briefly see the agenda, and then I will hand over to Raffaele to give us a bit of introduction about how we came to this, let's say, collaboration and about the vertical task force of the 6GIA. So this will be the opening and welcome. Also a bit about our AIOTI Working Group Agriculture, just that you see a bit of the background, how we came to this and where this collaboration was initiated. Then Alex from 6GIA and Luis from our Working Group Agriculture will provide presentation about the paper and recommendations. And then we will have the presentation of the use cases from the COMET project, and then questions from the audience and wrap up. So without further ado, Raffaele, I'm handing over to you to present briefly 6GIA Vertical Task Force and also a bit about background, how we came to this idea to collaborate and come with this hopefully useful paper. Thank you.
Yeah, absolutely, Damir. Thank you very much. Okay, are you controlling the slide? Okay, fine.
Yes.
Okay, just a few words. First of all, thank you to all the friends of IoT who collaborated in this very important white paper. This white paper is a product of the Vertical Task Force, which is a special task force which was created within the 6GIA board a couple of years ago now. I am a vice chair of the 6GIA board, and I'm also responsible for this very special task force. And so what is the scope of this task force? The scope of this task force is first of all to perform some industry influencing. So we try to influence vertical stakeholders on 6G and now on 6G, mainly through events participation. So we try to select with our vertical partners which are the most relevant events that we should tackle during a year, and then we participate to this event with with important speakers, so high-level speakers. So usually there are board members of the 6GIA that are participating into these events. Then we do ecosystem building. So we create partnership with our with the vertical industrial sectors. Usually this happens through MOUs, so through memorandum of understandings. So in the next slide you will see a full list of partnership we were able to engage in those last years. Then we do industry orienting. So we created a couple of cartographies on 5G PPP and SNSJU projects, so that all industrial partners can orient themselves amongst the project that we are running. And finally, we do orchestration and dissemination of white papers, such as this one. So next slide. Okay, these are the main achievements of the Vertical Task Force, the Vertical Engagement Task Force. So we have been able to attend more than 50 events in the most diverse industrial sectors with high-level speakers. What we do is, of course, we promote those events and we do a post-event report. We do ecosystem building. We have signed 11 MOUs with the most relevant key vertical sectors in Europe. We have performed 3 cartographies of 5G PPP and SNSJU projects, and also brochure on trials and pilots, which have been orchestrated and promoted. And finally, we produced 10 white papers with our vertical partners, as this one. So in the next slide, you will see the full list of partnership that we have. We collaborate with the space segment through the European Space Agency. ESA, in the meantime, has become a member of 6GIA. We have a collaboration with Public Safety Communication Europe and the public safety space. PSE is not only a member, but in the meantime become also board member of the 6G AI Association, which witnesses the importance that we give to verticals in our association. We collaborate with EXO, so for cybersecurity. We collaborate with the 5G Automotive Association in automotive space, with Ertico in the transportation space. Also, Ertico has become a member in the meantime. In the media space, we have two collaborations, one with the European Broadcasting Union through the 5G MAG working group and the NEM association. We have a collaboration with 5G Connected Industry Association, the smart manufacturing sector. And then we have a collaboration with the Health Association through the 6G Health Initiative. They become also member in the meantime. Of course, we have a collaboration in our own industry, so in the ICT industry. And last but not least, with IoT, which is not only member but also a board member. So the slide doesn't show this. And so this is the whole ecosystem of partnership we have. So we seriously engage with industrial vertical players, and we try, of course, to produce to gather requirements, trends, and basic information so that we can shape our mobile technologies for the future. And within this framework, this collaboration has happened. So we started to speak with Damir, and we thought that having a paper on agriculture was absolutely key, since agriculture is one of the key economic sectors in Europe, and it will be most affected by 5G and then 6G technology. And of course, the agriculture is one of the key players of the twin digital and green transformation of Europe. So there are a lot of good reasons to collaborate in this space. So thank you for that.
Thank you very much, Rafael. I think we can go to the next one. And then I think, Luis, you are the best place to present a bit about AITI Working Group culture. So please go ahead.
Oh, well, if you prefer, Damir, feel free to present the AIOTI, maybe just a little bit, and then I can give a few words on the working group in agriculture. You want to maybe to introduce first the AIOTI? Oh, okay. Yeah, so, well, AIOTI, well, as you know, is the Alliance for IoT and Edge Computing Innovation. Well, we touch many different aspects of IoT and edge computing technologies, and we are not also addressing, let's say, technology issues, but we try to focus, I mean, on the opportunities of technology, of IoT and edge technologies on particular vertical sectors and value chains. So agriculture, as explained just now by Raffaele, is one of the key industrial sectors in Europe, and this is why agriculture has been always part of, I mean, one important working group in AIOTI. And the working group in agriculture, actually in AIOTI, has been existing from the very beginning. Well, I have been participating most of the time in the activities of the working group, and I've been chairing the group as well for many years until now. I'm lucky to come now with also with Christopher Brewster from TNO as co-chair of the group, and basically, well, as you can imagine, I mean, in this working group is about, I mean, realizing unlocking the potential of IoT and its technologies for sustainable agri-food and forestry value chains in Europe in this new era of the Green Deal. And basically, we deal, of course, with technology for the sector, but we are also constantly looking at the new European policies in this regard. For instance, the Common Agriculture Policy is one of the major things to have in mind nowadays. Well, basically, that's it. I mean, we also try to promote very much collaborative research and innovation, especially in the European projects, of course, in Horizon Europe program and others. And currently, the working group is about, well, almost 100 people participating there, representing more than 60 member organizations. And well, we have been active during the last years, well, in providing, let's say, our opinion and recommendations on some of the hottest topics, I would say, regarding technology, application of digital technologies, IoT and Edge in particular, to agriculture and environmental monitoring. For instance, our previous paper before this one we are presenting today was about the role of IoT and edge computing technologies in addressing biodiversity and environmental monitoring, taking into account all these well, new European policies which fall under the umbrella, under the bigger umbrella of the Green Deal policy. Well, we have also been very active in the preparatory work of the European Commission for the definition of the Common European Agricultural Data Spaces, and well, we have been collaborating in a number of activities also with the European Commission, for instance, in the preparation as well of the testing and experimentation facilities for AI and robotics that finally ended up in publishing a call for projects for the testing and experimentation facilities specifically for the agri-food sector. So we have been very active during the last years, and well, now it's great to have this also cooperation, this direct cooperation with our colleagues of the 6GIA, and try to start to put some light on what are the challenges, but also the opportunities that we see in the application of the future 6G technologies in the domain of agriculture. So I think that's quite a lot for for the presentation of the working group. So now I would like to give the floor to Alexandros to start with a presentation of the content of the paper, at least to give an overview. And also later I will also provide my view on the main, let's say, conclusions and recommendations. So thank you, Damir.
Thank you, Luis. Let's move to the next one. And Alex, please, floor is yours. Welcome.
Thank you very much. Thank you, Damir, and thank you, Luis. My name is Alex. We can go to the next slide, just to introduce myself. My name is Alex Kaloxilos. I'm the Executive Director of the 6G Smart Networks and Services Industry Association. For those that are not familiar, the 6G Industry Association is the private side. It was the private side representative in the 5G public-private partnership, and now it's the private side in the Smart Networks and Services joint undertaking. I would like to say the following. I mean, for myself, and I think for all the people participating in the preparation of this white paper, it was a very useful exercise because there is a question what 6G can do for agriculture. There are several ongoing discussions how the technology can improve the agricultural process. I can tell you that even in the time of the 5G PPP, there were several projects dealing with 5G as an enabler for agriculture. And there are even projects now working for solutions as 6G networks for agriculture. But the elephant in the room, I think, is the following. It's not a secret that there is a mismatch between the expectation from people about what 5G and now 6G can do, and if there has been an adoption of the solutions by the community, in this case, the agricultural community. So the purpose of this white paper was to investigate as thorough as possible, and of course it's not an exhaustive list, but brainstorm and discuss and exchange ideas on what exactly 6G can do for the agriculture that even 5G, and I have to say that 5G, despite the slow adoption from the verticals, is an excellent network. Not only in terms of the typical network KPIs like delay, throughput, there has been significant improvement compared to the LTE, but also in terms of flexibility. And the question now is what even 6G can do that 5G cannot do already. So if we can go to the next slide. It was a joint team, thank you. It was a joint team between people from the connectivity world and the people from the agricultural world. And we have investigated in depth 4 areas. One of them is about novel farming techniques. The other one is about environmental and biodiversity monitoring. The third one about sustainability in terms of energy consumption and carbon pollution footprint. And the final one, precision agriculture and aquaculture. And we have tried to identify, okay, what is needed. And in my last slide, I will try to present what are the 6G enablers that indeed can deliver some of these solutions. So without any further delay, we can go to the next slide. Let's take, for example, the case of what are the challenges in agriculture and aquaculture relevant to 6G. There are various areas that we have included in the white paper. The first one is about sensing and monitoring. And I will spend most of my time in this first slide because in terms of technology, there is some repetition in the other areas as well. So bear with me for the next few minutes. First of all, you see that we are discussing on things about ultra low power communications, collect data. And it's quite well known that LTE is a very good system. 5G is even better, and there are already some specific solutions how to provide low power consumption IoT devices. But in 6G, the expectation is that we can do even better. And it's quite easy to understand that ultra low power communication is extremely important because when you are on the field, you don't want to go and replace batteries quite often. The second thing is adaptive bandwidth. We have different services. Some of them require low bandwidth, okay, and low throughput, which is quite okay. But in some other cases, for example, when we want to transfer a significant amount of data, but even in cases when somebody wants remotely to have a high definition quality video to monitor things that are happening, then that's an important aspect. As I was saying before, 5G is an excellent network, but it is one of the remaining weaknesses, the spectral efficiency on the uplink. So when you want to have on the uplink very good performance, there is further room for improvements in terms of spectral efficiency. The ubiquity of communications, especially in remote areas. 5G and 6G are competing with alternative technologies. I mean, in some cases, they can be competing with fiber to the home and Wi-Fi and this kind of activities. Fiber to the field is not an option because of the cost. So an alternative, the obvious alternative to the ubiquitous coverage is satellite. But again, there are currently, although there have been work to integrate to some extent satellite communication even with 5G, we all know that this is limited to very specific things of low throughput. So beyond 5G and 6G, especially in future integration, tighter even integration between satellite communication and terrestrial communication can bring further advantages to the table so that people may use their devices either in some cases connected to the satellite systems or in other cases with the 6G systems. So we can have further improvement in terms of coverage and of course with the supported quality of service that it is needed in several of the cases. The next point is the accurate geolocation. Of course, there are several solutions again already, but one of the key trends now for 6G networks is this joint communication and sensing activities that could allow the adopters of these solutions to have high precision even indoor. And this in a similar way, using the same network that they are going to use for the communication of the devices. For sensing and monitoring, we need to have a high spatial density of sensing devices and also of different types. And of course, 5G is delivering quite well, but even in this case, there is always room for further improvement in terms of 6G networks. The device security. Security is one of the important points in terms of the future networks. Again, I have to say that comparing LTE to 5G, at least from the network connectivity security, it's much more improved. But also, it's not a secret that we are going to, in a virtualized and softwareized environment, there are discussions about exposing interfaces to the verticals so that they can use the enablers of the network. And of course, this creates a more increased space of threats for the network and the applications using the network. So 6G will, by design, have a much more improved end-to-end security solutions. Zero energy devices, it's also one of the topics that is being investigated, or close to zero energy devices, further investigated in 6G networks. And similar things we can see for the other topics, like the farm management systems, where again we want to have, in some cases, high definition remote sensing imaging, decentralized data analysis and decision making. That's something that I haven't covered. One of the things that 6G is promising to bring to the table is the native AI support. Of course, everybody's using AI as a buzzword these days. And of course, AI can take place in various layers, from the application layer to inside the network, like a 6G network. But clearly, 6G networks have a wealth of information, and they can provide AI as a service to vertical developers. And this decentralized, when we say decentralized data analysis, because another key topic that we are discussing in 6G is the cloudification, and specifically the telco edge cloud solutions that can be used between various different cloud providers. Doing AI and machine learning, analyzing the collected data in a secure way, it's something that 6G will do much better compared to 5G. Low latency and real-time deterministic capabilities. Low latency, one of the solutions for low latency is, of course, having the edge cloud, because we are closer to the actual users, so we don't have to have huge delays in the communication. And deterministic capabilities, that's another feature of 6G. And in some cases where we want to have a precise and predetermined time for reaction in a specific system, 6G, currently the research and innovation activities are working to provide solution and offer such capabilities that are not available these days. Now, energy efficiency or interoperability as another topic. I was saying before, interoperability between satellite system, terrestrial system. Of course, there are drones also that can be used in the picture. People are also discussing about high altitude platforms. And not only that, 6G is going to support a number of various different access technologies, as we have seen also from previous legacy systems. So it's going to be one solution that is going to cover multiple various radio access technologies. Now, another point that 6G is quite a hot topic is this bringing together the virtual world with the physical world. And 6G can offer something that the previous networks cannot offer, is this digital twinning. And there is the representation from the physical world into a virtual one. Solutions can provide simulation, predicting the future, what is going to happen. And before anything bad happens, they can provide some solutions and some suggestions to the end users. You see a footnote, because as you may understand, these are copy-paste pictures from the white paper. When we say real-time, what do we mean real-time? Now, that's different for the different services. Real-time, for example, in some cases, especially for outdoor farming, could be in matters of seconds or minutes. In some other cases, for example, in greenhouse environments, people may want to have reaction time in terms of hundreds of milliseconds. So it's not that critical to go to 1 millisecond response time, but having the actual reaction time to happen much faster than what's happening today depends on the actual service. Then you see that, again, low latency, deterministic networking, and of course, another point which is horizontal across various vertical domains is to give the possibility to the service developers to create new services, easily deploy these services over the networks, considering also points like computing and networking requirements, and have what we call this cloud continuum. Again, this is a topic that only 6G networks will be able to offer. Finally, one topic which is about autonomous and cooperative machines. Even several years ago, I have seen even tractors to be able to operate remotely or even autonomously, or even smaller devices. And of course, this could be a significant help for the farming sector. Expressing just a personal opinion, we can consider a tractor like a vehicle, for example. And we all know that there has been a lot of work to provide autonomous driving. The thing is that for autonomous driving, it's one thing is the technology, and the other thing is to have the autonomous vehicles that communicate with each other out in the streets and use them in real life. This will, again, I am simply expressing my personal opinion, this may take some time because legislation is not there, but it's going to be much, much more easy to deploy autonomous devices in the field because the density of the actual people and the possibility for an accident is much, much lower. So we could, if I can make a prediction, we could choose solutions like that to be adopted even earlier in the agricultural sector. Now, as I promised, I spent too much time in the first slide. We can go to the next slide, where again, we discuss novel farming techniques, again, with smart sensing, autonomous and cooperative machines, or digital twin for different activities, like, for example, crop and animal growth, pest management, environmental conditions, energy efficiency, all the things that, and I know that there are plenty of applications even today. And I know that the community of agriculture has been very, very active in the past years to deliver new solutions. But most of the things that 6G can offer, I have already explained. So from security to autonomous machines to spectral efficiency on the uplink, for security, for data management, all of these things we see that are applicable for novel farming techniques. And then we can go to the next slide, which is environmental and biodiversity. Again, you see that for monitoring and surveillance, we have data that we want to collect from various remote regions. And of course, then we can have a combination between terrestrial and non-terrestrial networks. And in 6G networks, the terrestrial networks could even support higher transmission rates. Using joint communication and sensing for even geolocation, but also for indoor geolocation. AI and machine learning, so I don't want to repeat again and again, simply to verify that even for environmental and biodiversity monitoring, 6G can offer specific solutions. We can go to the next slide, which is about energy consumption and carbon pollution footprint. Again, we have for monitoring and surveillance cases where 6G networks can offer specific solution. And then we can go to my final slide and leave some room and minutes to Luis to provide the final conclusions. Do we believe that there are 6G enablers that are going to be useful for agriculture? Yes, clearly. As I was saying before, global coverage, somebody even today can say that, yes, we have already satellites and we can use this. Indeed, we have, but what are the services and how costly are the services to use the satellite? Also, if we can use 5G, yes, indeed, but can we do better in the uplink spectral efficiency so we can achieve in the uplink the required throughput for passing, for example, high definition video. 6G can deliver these kind of solutions. The second topic is about seamless spectrum access for different technologies. And 6G can be the integrator of various radio access technologies even for terrestrial drones, hubs, etc. Throughput, I have already discussed before that 5G is a very fast network. That's for sure. But again, in the uplink, we can have some further improvements, as we can have for the machine type communication, the term that was introduced in 5G networks. But even today, we can do much better with. We will be able to do much better when 6G solutions are in the market. Edge computing, it's quite important, closer to the user, but we need to have some cloud continuum between public cloud, private clouds, clouds offered by different operators, have the exchange of information transferred in a secure way. Having AI to be offered as a service even from network operators. The improvement and holistic end-to-end security provision, including from the services to the network and the end devices. An integration with data spaces where the collection, processing, and distribution of information will be possible, and doing this in a secure way, as the previous bullet. Energy consumption, working on IoT devices that will be close to zero, their energy consumption. This is something that will be delivered in a more efficient way in 6G networks. Finally, this joint communication and sensing enabler, where we can have the same network infrastructure, not only for exchanging information, but also sensing and helping us even for positioning or any other applications that joint communication and sensing can deliver. Apologies for taking too much of your time. Luis, the floor is back to you.
No problem, Alexandros. There is plenty of time. Okay, so well, thank you very much. I mean, you give a good overview of the contents of the paper. Now, I would like to focus on very briefly on some of the main findings. The part explained by Alexandros was a kind of, let's say, prospective thinking. I mean, thinking in a forward-looking manner of what will be the needs of agriculture, let's say, in 2030 and beyond. Looking at the trends, looking at what is, I mean, the current deployments and the directions where that agriculture are following. Another part of the report was devoted to see what is going on currently in innovation projects in agriculture, and the role of network services, communication networks in these projects, and the impact that they're having in this project, to see if we were able to get some useful conclusion. So very briefly, I will give just well, 4 or 5 bullet points regarding this part. Basically, I mean, the most obvious basic conclusion that we get so far is that, okay, 5G networks are already being deployed. If you look at the data about coverage of 5G networks in Europe, you will see that we are very advanced in this regard. But when coming specifically to agriculture, to the agriculture domain, we are clearly in a very early stage for the moment. And what we can see, even if let's say the size of the sample we use for getting these conclusions is maybe small, but clearly, I mean, it points out that the technology, I mean, 5G technology is still being deployed mainly as proof of concepting, most of all innovative projects. I mean, projects which are supported by public funding for developing new solutions and investigating new treatments and so on. But as we have seen, as Alexandros has been explaining, when doing this prospective thinking of agriculture needs in a few years, it's clear that the demands on the communication network are expected to grow very, very fast, exponentially. So it's very likely that the requirements for the incoming communication networks will very soon exceed those of the current 5G technology. So we need to think of this when designing the new generation of 6G technologies. And thinking of major drivers for the agriculture sector, I mean for these networks in the agriculture sector, clearly we can identify two of them that were already mentioned by Alexandros. Artificial intelligence is clearly one of these major drivers. When talking about 6G networks, we must think beyond just transferring data from one place to another. Of course, this requirement will be there with high reliability, high bandwidth, low latency for supporting many of the use cases and needs of future agriculture. But we need to think of the need to supporting natively, if possible, the integration of artificial intelligence, machine learning, and other advanced intelligence services. I mean, we will need a complete integration of the networks and the applications that they are supporting. The second major driving force we can say is well, the adoption, the increasing adoption also of the autonomous vehicles and robots in agriculture. So these vehicles, whether they are tractors, whether they are UAVs or whatever, I mean, they are expected to be autonomous in a way that they will be able to take decisions on their own. But most of the time, I mean, these decisions will need to be taken in conjunction with other variables which are not, let's say, managed directly by these vehicles or these robots. So it means that we will need to take decisions on the edge, on the cloud, and so on. In this regard, for instance, communications with the edge will become much more important than they are nowadays. And we must not forget either that these autonomous robots will not be, let's say, performing alone in the field, but they will need to cooperate with other vehicles, other robots, even with human operators in the field. So we need, let's say, to apply a lot of intelligence on the cooperation of these devices, of these vehicles, and also we must think of safety, let's say, requirements to guarantee the safety of the human operators as well. Next slide, please. Yeah. So this was also mentioned by Alexandros or by Rafael, don't remember, that currently there is a mismatch between okay, the expectations and the reality. What we found out is that even in, for instance, in Horizon Europe or Horizon 2020 projects in agriculture, when there is need for networks and connectivity services, usually these are assumed to be available, ready to use for the sake of the project, but most of the times, the case is that these existing networks are not fulfilling the requirements for supporting the use cases that are needed to implement. So many projects face serious limitations in this regard. And even the viability of demonstrating the results of the project sometimes depends to a large extent on the proper functioning of these networks. And this leads to another, let's say, big conclusion. And the situation is that, there are many serious connectivity challenges still in agricultural and remote areas where there is a lack of wireless network coverage that are hampering and will hamper more seriously in the future the adoption and the development of advanced artificial intelligence-based services in agriculture. Well, this is a serious situation nowadays, and well, as Alexandros mentioned, then the next generation of cellular technology, 6G, there is let's say a strong objective of integrating, of achieving this objective of global coverage very seriously, integrating, for instance, non-terrestrial networks, which nowadays, you have this possibility, but it's not a real possibility. It's not a real alternative nowadays because of cost, because of maybe the difficulty to integrate these networks with other terrestrial networks and so on. So this is one of the major challenges that need to be overcome and that need to let's say guide the development of the next generation of cellular technologies if we want to make a real impact in the agriculture sector. And finally, the last reflection is that what we have checked in this, let's say, sample of real projects, innovation projects, is that very few of them are specifically considering advanced 5G networks to implement and test their use cases. As we said before, the connectivity is expected to be there and to perform well. This aspect in the projects is not being taken into account very seriously, I would say. And in this way, let's say people are concerned when things are not working. But we must go one step before and think of, what are the kind of wireless networks that we need, how they should perform in order to be able to support the use cases in the projects. And in this way, we will be able to assess in a more systematic manner, if the existing technologies, the existing services are sufficient, whether they are not, and what are the required next steps. And of course, this is something that is not being done currently in a systematic manner. So my final slide, please, is based on these findings and in these reflections, is a proposed way to move forward in a way that we need. It's clear that we need a more systematic approach. To identify the needs, the use cases for agri-food activities in Europe related to these advanced communication networks and services. And we need to do this in order to proactively detect the opportunities. And for this, it's essential that we involve from the very beginning, from the initial stages, the users, the final users in the agri-food value chain, and we put them together with the ICT experts, with the people developing the next generation of communications and network services. Both kind of factors working together to identify very clearly what are the pains from the end user point of view, and what are the gains that we should be prioritizing. And in the next part of this webinar, we will be able to see how at least there is one project. There are more, of course, in Europe, which are addressing this need, and this is the case of the Connect project. And before going to that, two additional recommendations in this regard. We did this, let's say, limited survey on what's going on in several innovation projects coming mainly from Horizon 2020, from Horizon Europe programs, in order to understand what is the situation. But we need to do a more, let's say, comprehensive analysis of what has been going on. We need to inquire these projects, even if they are still ongoing or they have been recently closed, to understand what have been the real challenges and pains related to networks and communications. And this will help us to refine and complement this forward-looking analysis, this prospective analysis that you can find in the paper we are presenting today. And then finally, let's not focus only on what's going on in the innovation arena. I mean those publicly funded projects, but let's focus also. I mean, let's pay attention also to what's going on in agri-food production. In the real production of food in Europe, in the agri-food industry, because what we have found is that there are no clear figures or statistics about what's going on there in terms of utilization of connectivity solutions and network services. We don't know exactly what kind of technologies are being used so far, what are the limitations that are being found. And for instance, in particular, I mean, there is one 5G observatory, which is doing this kind of statistical data collection all around Europe, but as far as we know, there is no specific work taking into account, for instance, the agri-food sector in Europe. So one good question is, okay, and actually we have been asked this question by services in the European Commission. What is the current rollout of 5G in Europe in the agri-food sector? We don't have a clear idea, so that's a good starting point to work on. So thank you very much, and I think now it's time for the presentation of the use cases. So I will give the floor to Damir. I see there are a lot of comments going on there, but after the presentation by Serjan, I think we will have time also for opening. Turn for questions and comments and so on. So please, Serjan, go ahead.
Okay, thanks, Luis, for the presentation so far. So as Luis mentioned, I will be talking about mainly experiences from the COMECT project, although as on the next slides, or the next slide, there is a list of all the different projects that provided use cases that were used as an input to the paper. So it's not just COMECT, there's quite a long list. However, what I will share is mainly what we have done or what we are doing still in the COMECT project. Damir, will you share? Okay, yes. Perfect. So just a few words about the COMECT. It's a Horizon Europe project. It is focused on rural communities and bridging this digital gap between rural and urban, and mainly focusing on connectivity aspects, but also then building on top of that on different digital solutions that can help rural communities to thrive and to make the life easier, or to make the operation they have to do much more efficient. We have 5 living labs in the next on the next slides, Damir, that are focusing on different aspects of rural regions, from forestry in Norway to olive production in Turkey, and looking into different aspects of these activities and what type of different infrastructure, communication, energy, some digital solutions are needed to make all these operations in like be it forestry or winemaking or olive production, how to make it more efficient, and what type of communication technologies are needed, what type of digital technologies are needed to really make it efficient. So in the COMECT project, the living lab that I'm involved, it's on the next slide. If you know it, it's in Serbia, in the north of Serbia, where we deployed different types of technologies in a very much agriculture area. So it's a rural region. It's a small municipality. Agriculture is the main industrial sector that they are focusing on. And what makes it a bit specific is that it's bordering with a nature park. So it's a lake. It used to be a river before, and it's a protected area. You can't use like engines, boats with diesel engines. You can use only electric boats. You can't touch anything there. All the birds and all the plants there are protected. So and it is literally on the border or squeezed in between all the agricultural land. So we're looking into how we can help the rural community that is there to do their agriculture operations more efficiently, and at the same time help them have some insights into the environmental aspects of the whole area, how this environment is protected, if there are any particular issues there, and how that information that we collect can be used to increase the tourism, which is becoming an important aspect of their living there. So on the next slides, there are some end user needs that we kind of addressed. The colors are here somehow masked, so it's not really visible, but doesn't matter too much. So on one side, you have a very strong farmers community, and they obviously need access to agriculture expertise, also environment, because weather is having a big impact on agriculture operations. And then this environment and the environmental aspects, the water pollution, air pollution, etc., they're all potentially influencing the tourism aspects of that community, which is then influencing a lot of jobs as well. To collect all the data that is needed to monitor agricultural practices and environment, you need a good network connectivity. And yes, there is a good mobile network coverage. In this case, 4G, there is no 5G yet. But then for different types of sensors, that's not always the easiest way to just connect it to a mobile network because of the battery issues. Or the cost. So we had to look into how we create some network to make network which is suitable for collecting required data more easily available. And then, since we are talking about the nature park, the water, the fields, agricultural fields, there is no power plug that you can just plug in your gateway or edge machine learning device. So you have to provide some energy infrastructure as well. So these were the main three things that are driving the efforts that we have in this Living Lab. And then on the next slide, the main use case for this Living Lab is about providing this shared rural infrastructure, communication infrastructure, energy infrastructure, and also computing infrastructure. So what we are doing there is we are with a partner. We have these mobile solar trailers. So it's like a tractor trailer that is converted into a mobile renewable energy power plant that you can just hook onto your tractor and drive it to your field. And they've been using this for quite a few years now. They are using it to run their irrigation pumps during the agriculture season. Then they move them back during winter, and then they use it as an additional source of energy, so to lower the energy costs. And what we said is, okay, so now that we have energy there in the field, we can also add more things onto that. So first thing that we put was the LoRaWAN gateway, which enabled us to deploy a number of different sensors, soil moisture, soil humidity, weather stations. There can be a number of different things that you can measure there. And now that we have a LoRa network coverage, we can collect a lot of data. Then, we equipped this the tractor trailer, we equipped it also with the weather station so that we have that information. And then we added video cameras, and to video cameras, we need for two things. So on one side, it's monitoring the crops growth, the status of the crops. And on the other side, also for some level of security, because things happen and people steal the crops, they steal the equipment. So we put it there as one way of kind of a deterrent to these type of activities. Of course, streaming video feeds from the field 24/7 over mobile network, it's not feasible. I mean, if nothing else, it will be very costly. So that's why we put an edge machine learning gateway there so that we can process all the data and we get intelligence in the field, directly in the field. So all the data that is collected from the sensors, all the video streams, they're processed there on the edge, and then the results, the outcomes, what is important is sent to cloud for further processing and further notifications. And with this setup, we have one kind of a static solar plant and then two mobile. We can cover quite a large area there in the field of this municipality, providing LoRaWAN connectivity to everyone. So not just for the farmer who owns the tractor trailer, but for the community. And then also building some digital platforms on top of that that can provide information about how to do different farming activities, and also what to inform them about the environmental conditions, and so that they can be used as an input to some business decisions of maybe municipality regarding tourism, or just for general information for the people living there, how what is the status of the environment, what is the status of the water, of the air, of this nature park there. In another living lab, which is in Norway, on the next slide, it's about forestry. And okay, so this is just to show that we don't have just graphics, but we are doing something in the field. So these are just images from the deployment. On the next slide, it's about the Norway Living Lab and the forestry there. And it's maybe 2-3 hours drive from Oslo. It's very impressive. We went there as part of one of the project meetings, and it was very impressive for me to see these machines, how they work, how quickly they can cut the tree, remove all the branches and everything, and just put it on a big pile and prepare it to be transported. It's a really impressive machinery just from the engineering perspective. But on the next slide, you can see that there are a lot of things that how you could help with digital technology to the operators of these machines, because machines, as good as they are, they can malfunction, there can be some faults. And when you are so remote in the forests, you need some help, and sending technical personnel to help you, it will take them 2-3 hours. It's not really efficient. So Living Lab there is looking into setting up a private 5G, connecting it to over some terrestrial network to the remote center operators, so they can have this live communication, not just live kind of talking to the operator, but also getting all the data from the machines and being able to remotely fix some of the problems if they are remotely fixable. And also giving guidance to the operators of the machines. In some cases, it's not always clear which tree to be cut, or should they cut this one, or maybe it's a protected one, because there are some different rules and regulations, what can be cut, what can't be cut. And then with this type of setup, you can help the operators to do their job much more efficiently. At the same time, on the next slide is the other use case where some of this deploying different types of sensors to monitor the fire forests, for example, and using a bunch of different sensors, so using edge computing to process all the data, and then sending it again to cloud and notifications to the community. That's part of this use case. And the Telenor, which is one of the partners there, they're looking into deploying these mobile, private 5G put on a truck, and then covering that region with all the necessary connectivity to connect these sensors, or connect drones, and getting the data from these, processing them on the edge, and then sending over. Similar to what I just described there in the case of this agricultural land in Serbia, just a different case, but the set of technologies is the same. The set of technology that is required, energy sources, communication network, edge processing, and a combination of sensors, is the setup that is required to support these type of use cases. And the last but not the least, the one in Luxembourg is talking about, or looking into, vineyards. Much nicer environment than forest, at least not as wild as the forests. And there, okay, I think on the next slide, maybe the usual thing that you do in vineyards is putting weather stations and monitoring soil moisture to look to be able to predict potential diseases of the vines, and then provide some recommendations around how to deal with that, how to prevent them, or how to reduce the impact of these diseases based on all the environmental conditions. In this Living Lab, if you can just move one slide, please. There is we're looking into creating one more maybe. Looking into creating these digital twins of the vineyard. So, and to create digital twins of the vineyard, you have to collect a lot of data, and then it's superimposing leader camera measurements and also normal video camera feeds, and then combining them into creating this type of digital replication of the vineyard. It requires a particular setup. And on the next slide, there is some slides or some visualization of how it's done. So it can be done just, okay, the first thing was just using normal mobile phone camera and then walking through the vineyard and collecting it. But that's more just as an indication what could be done, or to see how the process could go. And then it's equipping, if you can just go to the next slide, please. It's equipping tractors with cameras that can, one more, please, that can collect the data through, as the tractor is going through the vineyard, collecting all the data and then combining it into creating these type of images that were shown there. Of course, sending all the data again, especially video feeds over mobile network, is not really a way to go. This is a huge amount of data. So being able to process that data there locally and then send only the results is something that is definitely the way to go. So I think if I just take it from the comment perspective, overall, through all of these three use cases and then all living labs, and there are two additional ones that have similar issues and similar solutions. You need energy, because in the field you definitely don't have power sockets that you can just plug in. So you need to provide that energy. And luckily now these solar panels and are quite effective. You can do a lot. And if you combine them with this or make them in the format of these solar trailers, you can move them around. So it's becoming very good solution. And then equipping those with the edge computing capability, with networking or communication network capabilities, especially LoRaWAN or something similar that you can use to collect data from battery-powered sensors from a large area. And then adding specific types of sensors that are useful and required for a specific type of application, you get a solution that is working well. With 6G, I think some of these things will be, at least I expect, will be even more easier to implement, because you would be able to combine a lot of the functionality into one box and get these sensors to work directly on 6G instead of having this LoRaWAN, then 4G or 5G step, and being able to work with a larger number of sensors, or that sensors can go there, will be deployed and work for many years. I think that's pretty much probably the last slide that I had there. I tried to be rather concise. Yes. But if there are any particular questions, I'll be happy to answer.
Thank you very much, Serjan. Very much to the point presentation. And yeah, I think for more details, well, I mean, people interested can go through the report, which is already available, or of course, I mean, they can contact you. We have a few minutes, I think, for questions. People have been writing some questions in the chat. For instance, there is one question by Laurent from Orange asking about the 5G network in the forestry use case. In particular, the question is about how is the 5G network tailored for forestry, because this was one of the things you mentioned during your presentation, Serjan.
How the 5G is deployed in the forest. So that's, as I said, one of the parts, especially for this use case or the Living Lab in Norway. Telenor Norway is the lead partner, and they have that, well, how I call it, private 5G in a box. Well, the box is a truck, so it's not really a small box, but still they can do it that way. And this is what they are working on at the moment. They have some installations done already in or proof of concepts, and it will be deployed in the forest as well. If that was the question, yeah.
I think so.
Yes, thank you. Just yes, to complete, would have been it different with the 4G?
Well,
Do you really use specific features from 5G or?
so some things can be done with 4G already. So depends, I guess, how you maybe define this 5G. But the first living lab that I was showing there with this solar plant and stuff. So that's a combination of LoRaWAN and 4G. There is no 5G as such. Similar thing you could do in the forest as well for quite a few things. But for some of the things, I think, especially if you want to do some remote steering of this big machine or something like that that requires much shorter delays or a more reliable communication, then I think you would have to go 5G. And for collecting sensors and just sending them, or like 4G plus edge computing would be sufficient, at least in my opinion.
Okay, thank you.
Okay, there are also several comments, regarding, the cost of this, of this technology as one of probably the blocking issues for adoption. Then we have also the availability, of course. Networks. Many areas for agriculture are void of any connectivity, and this is a consequence of the standard model, let's say, for telecommunication operators. Is not let's say viable economically speaking in those areas probably. So I guess one of the conclusions is that is also pointed out from some of the people attending the webinar, is that we need to think of new ways, new business models, and also think of new structures, to deploy the connectivity in these areas. You were showing, for instance, this shared infrastructure for having energy, for having connectivity. This is, let's say, out of the usual business of the telecommunication operators. But it's clear that we need to think from this more imaginative side, to try to solve the problem.
Yeah, definitely. I think that this is one of the reasons why we did the cost and the availability of it was why we wanted to go towards this shared infrastructure. Because then with a couple of these solar trailers and a couple of LoRaWAN gateways, you can cover a really large area there. Because at least in agriculture's case, in our case, because it's really flat, and the largest thing that obstructs your point of view is a big pumpkin. Everything else is just flat. There's nothing there. So it's easy to cover a large area. And then if you have a few of these solar plants with LoRaWAN gateways, you can get a lot of connectivity that everyone in the community could share. We try to talk to the community there about sharing these solar plants and saying, okay, one is you are raising corns, the other one is peppers, I don't know, whatever, they're irrigating different types of crops, and let us, based on the needs of the plant, based on the weather, the soil condition, decide when you have to run your irrigation system so that we can move this around. But that was a big almost no, we want to have our solar plant and be able to run it all the time, irrigation system. So there's also work on the community side to understand that this sharing economy could work for them as well, without affecting their main business, the core operations, or without affecting their irrigation plans or activities. So it's a process, and we are working with some of the mobile operators that they offer these similar solutions or digital farming solutions to their users, while at the same time offering at least LoRaWAN connectivity in agriculture areas, and trying to offset some of the initial costs, which are mainly related to deploying the network, take them outside of the equation at least, or at least move them into some sort of a monthly cost that would be similar to the cost of your mobile phone or a cable subscription.
Mm-hmm.
Luis, I think
Thank
we
you.
have one question from Michael in chat, and then we have Ton and Edgar raising hands, just to keep some sort of order.
Okay, Michael, you said Mike. Sorry, I
Michael,
didn't.
actually, so he says the case in Luxembourg. are the
Okay.
tractors moving autonomously. We are working in a
Okay.
similar environment, the tree nursery business, and need self-driving robots.
Mhm.
So I guess this goes
No,
to
no. So the focus of the project was not on creating a full solution for collecting the data. It was more on just using, if once the data is collected, to create this digital replication. So if you are working on the solution that has that enables collection of the data in a very, I would say, simple manner, I'll be happy to talk to you or to connect you to Maria Rita, who is responsible for this living lab in Luxembourg.
Okay, thank you. Yes, we'll work on this. Yes.
Yeah. So just send me an email or and then I'll make connections and
I
but
will-
I'll be in learning about
and
it
I will
more.
put you in touch because I think I have email of both.
Yeah.
Sure.
Okay, and then we have also the well, more than a question, I think it's a comment by Tom Norp. Okay, he says that of course agriculture is very wide, and depending on what side of agriculture you are considering, I mean the situation is different. Of course, extensive farming is completely different from greenhouses. Yes, I agree that in greenhouses there is a much higher adoption of technology. Usually it's more added value crops also that you have in greenhouses. Yeah, I mean that's why in the paper we tried to focus on different scenarios. I mean this precision farming in, let's say, a standard farming, and then also the novel farming modalities, including not only greenhouses, but also vertical farming, which is even more technology intensive because that's basically industrial production applied to food. Yeah, so I mean, the role of technology is, I would say, it's also an enabler for making this business viable, from an economic point of view. Yeah, but feel free to comment on your on your own, Tom.
If no comments from Tom, I suggest we go to Edgar, who is also raising hand.
Sorry, I was muted. I was.
Please go ahead. Go ahead, Tom.
Okay.
So you summarized it quite well. One thing is that I think that in general, looking at connectivity issues is always a good thing, whether it is because the farms are very remote, but even we found that if you have a greenhouse or probably also vertical farming, you have then still got indoor connectivity issues. We've been doing measurements on the effect of growing plants in a greenhouse on the radio connectivity that you have inside. So I think that having specific networks, like private networks, not public networks, specifically to address the connectivity, or satellite networks, I think is in general cases that is important with this kind of farming solutions.
Mm-hmm. Thank you, Tom. I agree. Okay, we have more questions coming.
Let's go to Edgar because he's having his hand for quite some time.
No problem. It's okay. Can you hear me?
Yes.
Yes.
Yes, great. I'm a bit curious about one or some statement that are in the white paper. They talk about the need for terahertz communication and millimeter waves. That would mean that basically the deployment would need to be most probably in a private network, meaning that the farm would have to either share a private network with other farms, and then I was wondering for what purpose. I mean, I know that, for example, they have been cases of the tractors that are being complained that they are not lasting long enough because they are having the intelligence in the tractor. And one way to improve that is leaving the tractor most as a remote control unit and putting the processing in edge. And then maybe you need to have some sort of very big bandwidth and high low latency communication availability. But then still thinking about millimeter wave and terahertz frequencies for that, I'm not so sure. So I'm a bit curious, what use cases did you guys have in mind when that was proposed?
Well, maybe I can give at least a first answer to this. As we mentioned, I mean, agriculture is, I mean, very, very wide. I mean, and for instance, extensive farming doesn't have nothing to do with intensive or indoor farming. For instance, when thinking of the usability of, for instance, of millimeter wave bands or terahertz frequencies, we are clearly thinking more on indoor farming scenarios. And in particular, this kind of, let's say, vertical farms where the density, for instance, of sensors and plants is very, very high. So you need to be very accurate. The distances will be much smaller and everything will look much more like, let's say, an industrial facility than a farm. So
But even in that environment, you still will have the shadowing problems, meaning that the sensors might not be reachable because the penetration loss is too high. So that's something that make me think, is it really something that it could be used here?
Yeah, I mean, not everything is is said in this regard. I mean, even if I mean for this kind of companies running these vertical farms, still, I mean, they are working on let's say being viable in the longer term, and this means for them, I mean, to be much more efficient in for instance, in what they are measuring, in how they are measuring let's say the density of these measures, and this will need for new technologies for doing these measurements, for communicating the data. So I mean, as we said before, this is prospective thinking. We think that working in these higher bands in the spectrum can help for some of the needs that we need to address in this kind of indoor farming scenarios. But as we said, I mean, we have more, let's say, guesses than certainties, for instance, in this regard for the moment.
Okay, now I get it then. So it's mostly focusing in vertical farming, and then we are thinking that maybe the volume of data and the devices need to be handled and could be handled by the use of higher frequencies.
And you have an environment with much more control conditions. I mean, it's not outdoor farming anymore.
Yeah.
I mean, this is like an industrial facility. So, I mean, this allows to think of technologies and frequency bands which are not, I mean, practical in those outdoor scenarios, clearly.
Yeah, a little bit like in manufacturing, where you have more control of your environment. Yeah, got it.
Exactly.
Thank you.
Exactly. Thank you.
Thank you very much. I see that there were some questions and answers in chat. I don't know if Chen, you want to maybe comment on because I think Fleming was trying to reply to you. So I don't know if you want to raise it again, or if there is any other question or comment, because we are close to the end.
Well, maybe just to add this comment on this Chen's question about having to talk to farmers or the close collaboration with farmers is required. That's definitely the case. So whatever you do in farming, you have to have very close collaboration with farmers and to have it over a long period of time. They don't trust you immediately, so you have to earn that trust, and you earn it by talking to them, giving them to try the technology, and showing the technology really gives the benefits that you are claiming that they are getting. And once you get that hurdle, then it's becoming much easier, and then they start to be advocates of your solutions. But without that, it's very difficult.
Yeah, sure. I mean, the approach you are showing in the Connect project, Serjan, is the right approach. I mean, to put both sides of the story to talk together and to understand each other. That's, I mean, that's essential.
Yeah.
Right.
Thank you. And I think this is also what Baharia from Nokia was mentioning, and this I think it's exactly the way that I think this collaboration can also in a way help, and I think this is also very important. Not only talk about technologies, because everyone can say I have a nice shiny technology solution, device, whatever, service. If people are not convinced that this is really bringing them a benefit, either by cutting their time or increasing their efficiency or cutting the costs, it will be very difficult to deliver. One thing which was also mentioned by Luis, not to hijack the discussion, but I think it's very important for the future discussion, is that funny enough, European Commission, at least they approached us from the DG Agriculture, asking us, do we have some information about the uses and the, basically, you can say the deployment about the technology and so on, which is quite funny because they are usually in touch with the member states and having a lot of statistics and statistical overviews and surveys and so on. So this is also something that we should kind of think about and possibly map or collect the experiences from the projects and then provide this to the Commission as a possible useful feedback, not only on the projects and what could be further steps in, let's say, research and innovation part, but also in the uptake of the technologies. What are the barriers, what are the challenges, and how maybe to overcome it, because otherwise it will be very difficult, whatever solution you have, to actually get through. What I want to say is that we need to get also as much as possible from the users, but also from the policymakers to kind of support the application of these technologies, and then also support the farming industry actually to uptake those technologies.
Right. Thank you, Damir. Okay, I think we are over the timing initially expected. So maybe I think it's a good idea to close the questions for now.
Yes.
And move to the final part of the webinar, which is basically, well, I will give the floor again to Rafael just to do kind of wrap up and farewell of the webinar.
Yes, first of all, thank you for all this participation. I think the webinar was really interesting for all of us. So thanks to all the organizers and to the participants. Actually, I have pulled together some notes. I'm not sure if I have still 5 minutes, and I can share my screen. Just a second. Let's see if this works. Oh, yeah, okay. Can you see my screen?
Not now, yes.
Yes. Now, yes.
Okay, just some final remarks. I took these notes because I think that some important topics were tackled. First of all, there's as it has been pointed out, a mismatch between promise and expectation is there for 5G. So 5G adoption in agriculture is still low in spite of excellent performances. So few innovation projects based on 5G and beyond the technologies. So this is really a pity. I think maybe there is a reason for that 5G in Europe is basically non-standalone. So we have to wait for the standalone version of 5G to deliver the full promise of 5G. We spoke a lot about enhanced 5G capabilities and new native 6G capabilities for the agricultural sector. So it has been pointed out that we need a high-level connectivity to develop new services. So 6G, massive type of communication, low latency performances will be enhanced with respect to the 5G. So 6G enhanced features may be a driver for adoption. So we will need more coverage we will have more coverage with satellite integration. As you may know, a satellite has been integrated within 3GPP standard. We didn't tackle too much private networks, so maybe private networks could be also a solution for coverage. Artificial intelligence as a service and integrated ESAC, so integrated connectivity and sensing will be important feature, I guess, for 6G. These are totally new features. So especially the sensing part, I think will be really interesting for the agricultural part. So network as a service intended as API access for secure exposure of network capabilities and innovation, I think it will be key. So accessing, 6G and 5G features through protected and secure APIs could be really interesting. Telco Edge Cloud to provide new services from inside the network. There's a lot of discussion also about in Europe in this moment at the European Commission level to enhance this Telco Edge Cloud in Europe to provide the new services closer to the final user. Digital twins have been addressed correctly to tie physical and digital worlds. And autonomous vehicles, hopefully electric, can be a game changer, especially for drones and tractors, to have less accidents and maybe less manpower. Okay, engagement with our community is key to define 6G. We will enhance this collaboration with the agricultural community. Shortly, we will run an online survey that will be distributed amongst key verticals to gather inputs and key trends and use cases. This is part of the SNS ICE project. So you will receive an invitation to participate to this online survey. Then there are socioeconomic drivers and barriers. As it has been pointed out, poor incentives to cover rural areas for operators beyond the regulatory constraints. Environmental sustainability can be a driver, I hope. A digital green transition, are there incentives to leverage there? Climate change and an opportunity to accelerate in agriculture, and finally shortage of manpower in agriculture to drive adoption on autonomous robots and vehicles. I took these notes because I think that these are all key. Some of them have been developed, other less. And so this is a stimulus for us to go ahead in this discussion with you in agricultural world. This would be all for me. So thank you very much again, and hope to see you on some new webinars in the next future and on this sector. Thank you very much.
Thank you, Raffaele. Thank you, Luis. Thank you, Serjan. Also, Alex. Thank you all for your active participation. I think you have quite interactive session, which was exactly the point. We try to provide some also links and some responses in chat. There will be also recording and the presentation available online, both on the 6GIA and AITI websites. And as Raffaele said, hope to see you soon on some other webinars. In the meantime, for all the ones who goes on a summer break, enjoy the break, and then see you soon. Thank you.
Thanks, Damir. Bye.